Well, once again, it's been way too many months, and I'm trying to get caught up on some stuff. This is the Ames PWRINV36W 5000 watt stepped square wave inverter, or modified square wave, I should say. That came back after I repaired it, and I went ahead and ordered every single replacement FET. You can see I've tested every single one of them. I've got their gain and their cutoff point listed on each one. They're all very, very closely matched. So this thing uses 32 FETs. And so I ordered just a couple of extras. As you can see, if you want to count them, I think that's like 36 right there. So I've got a couple extras. They all tested absolutely perfectly within a point or two of each other. And we do have some 10 ohm resistors there, and there that are bad. This side's completely fine. So I did go ahead and order a bunch of 10 ohm 1206 resistors to replace those with. And yeah, let's just go ahead and get started tearing this thing apart. Oh, soldering iron fell asleep. Gotta wake it up. And so I'm just gonna go ahead and scrape these resistors off the board once this thing gets warmed up. And we'll go ahead and attach the new resistors to the board. Now, as I recall, these resistors were just slightly out of tolerance. Let's go ahead and test them again. It's been a day and a half since I looked at this thing. So I'm just going to go ahead and put this in the 600 ohm range. And we'll do an ohm check on the lead. So if I can get them to touch, I see 0.1 ohm. So let's test this resistor right there. 10.1. And then this is open. That one actually checks okay, a little bit low, but I'm going to change it anyhow. I think it looked like it got hot. That one is open. Interesting. Why does that one... Did I goof up? Yeah, that one's totally open. 10.2, 10.2, and open. Well, yeah, it's a hair low. We'll change it anyhow, just to be safe. They're cheap, you know. So I'm just going to go ahead and add solder to both sides and just scrape the resistor off the board, just like that. I realize that it's still attached to the tip over here. And that one's gone. And that one is gone as well. Okay. Well, there are the three. You can just barely see them on the bottom of your screen there. There are the three resistors we're going to change. So I'm just going to go ahead and vacuum the solder off of one side only. That's going to allow me to set the new resistor down. Once I heat the one side, it'll fall into place. And then we can go ahead and solder the other half of the resistor. Move those guys out of the way. So I went ahead and I peeled back the tape over three resistors. Dump them out right there on the counter or on the bench. And let me get a little pair of needly nose pliers. And we'll just go ahead and try to attach this one first. A little bit of downward pressure and some heat. That one is in position. All right, there you go. The bigger the glob, the better the job. And we'll go ahead and test the ohms of them real quick just to make sure everything is good. Once again, 600 ohm range, so it does not auto range. We'll just go from there to there. And I see 10.1, 10.1, and 10.1 ohms. Perfectly happy with that. Now keep in mind, this is the master board right here. This is not the slave board. There's another board almost identical to this one, minus the microprocessor and a bunch of the switching over here. So the next thing I want to do is go ahead and replace all 4 of these FET drivers on this side and the 4 FET drivers that live over here on this side as well. So I'll need to unsolder those, get the new ones installed. Once they're installed, we'll go ahead and repopulate all of the output transistors and replace the blown fuses on both sides of the board, the master and the slave. All right, back on the bottom of the board, we're just going to go ahead and unsolder all of the driver transistors. Okay, I got all the driver transistors out. Just got to clean up some glue that was on one of them and reinstall some new transistors. And there are 2 varieties that this thing uses, 2N2907s and 2N2222s, or PN2907, PN2222. One's an NPN and one is a PNP transistor. So I ordered several of each. Go ahead and get those things installed into the board. All right, new driver transistors have been installed in both sides. So if you're doing one of these, the orientation is from this side, 2907, 2222, 07, 22, 07, 22, 07, 22. So let's go ahead and throw some FETs in this thing, and then we'll supply 36 volts to it and see if it wants to power up amicably, or is there another issue with this thing. Okay, well, as you can see, I do have 36 volts DC supplied into this unit. I haven't mounted the output FETs yet. I just want to go ahead and power this thing on. And I should get a voltage indicator right here, as well as a percentage of output right here. And I've got nothing at all. So that leads me to believe that this regulator may have been damaged in whatever happened to this thing. I think it might have been hooked up backwards. I'm not sure. But it took out just about every single FET, blew most of the fuses. I do have all new fuses installed. Like I said, I've not repopulated the FETs on this board because this unit will run without FETs. It'll at least power the microprocessor. I did go ahead and measure voltage on every pin, and I've got nothing on any pin whatsoever. So that leads me to believe that this switch mode, it's a buck converter, I believe, or a boost. No, it's a buck converter. So it takes the 36 volts and it regulates it down to 12 volts. So I'm going to go ahead and move some stuff out of the way here. We'll power this thing down, and then I'll just flip this upside down. And we'll get it more or less centered up so everybody can see it nicely. Move some stuff out of the way there. And we'll zoom in just a tad on it there. That might be okay. Get the meter set up right there. Hopefully you can see the digits. Yes, very good. All right, one moment please. All right, so I did go ahead and print out a schematic of the LM2576 HV-12, which is just 12 volt output. So what I want to find on pin 1 is the raw 36 volts. And then pin 3 and pin 5 should be grounded. Pin 2 is the output pulse. And then pin 4 is the feedback. So pin 2 and pin 4, I should have 12 volts. Even though that says 5, they just use the 5 as an example. This one is a 12 volt regulator. So I want to look at pin 1, 2, and 4 and see what we have there. Okay, so pin 1 is this pin way over here on the left. And let me go ahead and give this thing some DC voltage. Okay, and I've got DC voltage on it. And I do believe, now I've got to move this. Make sure I actually have the switch in the on position, which it is now. Get you reset up here. Okay, so pin 1, I've got 36 volts. Pin 2 should be the switched output. And I've got 15.8. What about pin 4? 1207. That is perfect. Oh, don't tell me it's got a cooked microprocessor. What is going on here? Unfortunately, I don't have a schematic for this unit. And I've never been able to find one. If anyone has a schematic, if you can share it with me, I would really, really appreciate it. It would help this customer get this thing back up and running once again. But let's just go ahead and measure the voltage on the pins of the micro. So remember, the power switch is on. So I've got nothing, nothing, I mean, virtually nothing. 0.1 is nothing in my book. I really want to see a pin that's got either 5 or 12 volts on it. And I've got nothing on any pin of the micro in respect to ground. So this being a buck converter does not have an isolated output transformer, which means I can continue to use my common chassis ground for my measurements. So yeah, well, there we are. Once again, things have to get more difficult than they actually need to be. All right, let me think about this for a few minutes and see if I can come up with a resolution. All right, Houston, I may have bitten off a bit more than I can chew. That is a transistor, a surface mount transistor mounted to the main board. I didn't notice this on the first go round. I'm sure that burned up transistor has something to do with why this thing is not working. So let me zoom out. It'll defocus for a moment and then come back in. And as you can see, it's in basically the microprocessor feedback circuitry. And yeah, I thought that was a burnt spot, but no. Doggone it. All right, well, I'm just going to leave it at this. Hopefully someone may have a schematic for this unit. I don't. I need one. I don't know what this transistor is. I've got no way of identifying this thing because this one is toast. So if anybody has any information on the Ames PWRINV series inverters, whether it be the 12, the 24, the 36, or the 48 Ws, which indicate the voltage input, I would really appreciate it, and I'm sure my customer would definitely appreciate it if you could supply that info to me so I can get this thing back up and running once again. So I'm going to leave it at that. I'll give you the normal spiel on the outro. You can follow me on social media, Facebook, Instagram, Twitter, or X as it is now, at NorCal715. You can email me, NorCal715videos@gmail.com. Once again, if you want to contact me, please leave me a comment on one of the YouTube videos. That's something I can actually check periodically. I haven't had time to check the emails, like I said, in months, just other than one here and one there. Yeah, everyone, thank you for making it to the end of this video. I really, really appreciate it, especially all the support that have come through since my daughter's accident back in January. Once again, it's put me so far behind with basically it's just been tough. Depression I'm just not motivated. Somebody in my family got hurt and I was powerless, and it really took a toll on me, unfortunately. Stress affects different people, well, differently. I'm trying to get motivated again. It just takes a lot to get going these days, not like it used to be. It's still fun. I love doing this stuff. It just takes so much to get motivated to do it anymore. Um, they are doing better. People have asked. Yes, they are doing better. 99% recovered at this point. It's just so much going on. Everyone, thank you for making it to the end. I really do appreciate it. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility, hopefully. Once again, if someone's got a manual, I really, really would appreciate it. Everyone have a great day. And once again, thank you so much for watching. Bye-bye.